Okay, well, I think now's a good time to do a few housekeeping and items before we kick off the webinar. So welcome everyone to LogRocket's monthly webinar. Today we are excited to have Joe Emison, co-founder and CTO of Branch Insurance, join us to discuss how Branch releases front-end features faster with minimal back-end effort. In addition to Joe, we will also be joined by LogRocket's co-founder, Ben Edelstein. Before we begin, I'd like to let you know that a link to a recorded version of this webinar will be emailed to all participants, as well as all registrants, and the recording will also be available at logrocket.com. At the conclusion of this webinar, we will have a question and answer session with Joe. If you have a question, please add it to the chat. I'll be more than happy to relay that information to Joe. All questions will be asked in the order they are received. If you have any questions that are not addressed by the conclusion of the session, feel free to contact Joe on Twitter at Joe Emison or contact us at LogRocket. For everyone still joining, welcome. And before we get to Joe, I'd like to introduce Ben Edelstein, co-founder of LogRocket, to quickly review some features we've recently released and go over a product demo.
Hey everyone, and thanks George. My name's Ben and I'm one of the co-founders here at LogRocket. For those of you who are not familiar, LogRocket helps teams quickly fix technical issues in their web apps and proactively surface issues affecting their customer experience. We do this by showing you videos of everything users do on your site, coupled with technical telemetry like network logs, JavaScript errors, and application performance. So when users report problems, you can see exactly what they did and what went wrong, and then understand the impact of similar issues across your customer base. So let me show you a quick demo of some of our newer features. Hey, George, I think you need to, yeah, there we go. So I'm going to share my screen and George, can you confirm that the screen is visible?
The screen is visible, Ben.
Awesome. So this is a demo environment of LogRocket, and let's start by imagining a user has reported an issue to us. What I can do is I can come in here and I can search for a user by name or by email. And when I type in this user's name, what I'm going to see is recent sessions of this user on our site. When I click play on one session, first I'm seeing a full video replay of everything she did. So this is really helpful. I don't need to go back to the user and ask her to send me screenshots or ask her to tell me the steps she did on the site. I can see exactly what she did and any errors or issues that she encountered, whatever was on her screen. And then I can open our developer view, which in addition to the video shows us every network request that took place. And I can click in here and see the headers and the bodies and the response from the server. If there was some sort of network error, I could click through our Datadog integration or our Splunk integration and other backend integrations to see exactly what was going on the back end at the time of this issue. Down here, you can see console logs, JavaScript errors. We integrate with Redux and other state management frameworks to see the application state at any point in time. Here are some details on like the user, who is this user, what browser and operating system and browser version they were using. And then our new performance tab shows you CPU usage, memory usage, and any browser crashes that may have occurred, so that if a user complains about a vague performance issue, instead of guessing, you can come in here and see if there was a technical reason why the application was slow, or maybe there was like a slow network request. So this is super helpful for understanding individual issues, diagnosing the problem and fixing it. But often we then want to understand how frequently an issue is happening. What is its impact on my user base and my customer experience? And that's where LogRocket's new metrics functionality comes into play. So I just clicked on a network error that I saw, and immediately LogRocket is showing me a very quick kind of high level number of like how many people this affected. And what I'm going to do is I'm going to click create metric, and I'm going to call this shopping cart load failure, throw this onto one of my dashboards. And I apologize for going through this part a bit quickly, but essentially what LogRocket is now doing is it's showing me retroactively over the past, and this is for a day, I'm going to set it to a week, over the past week, how often has this issue been happening? How many people are affected? And I can see here, this is actually affecting a lot of issues. So this is probably something I'd want to talk to my engineering team about prioritizing. And you can create metrics, not just from issues you see in a session, but I can also create a metric right here. So as an example, let's imagine I've been hearing reports that a certain error message is happening a lot. I'm going to call this error modal appears, and I'm going to create a metric around an element being visible with the text and an unknown error happened. This was the text in my modal that pops up on the screen. And again, when I hit save, LogRocket is showing me this fully retroactive analytics around how frequently this error has been happening. And I can even click into this graph and then see actual users that experienced this problem, how it affected their session and how it affected their user experience. So a very powerful tool for understanding not just network errors or JavaScript errors or error messages appearing on the screen, but when you can build metrics based on user activity, like users having clicked on something, and any combination of the technical signals or application performance to better understand the frequency of issues, to better understand regressions, to better understand performance in your application. So that concludes my super quick demo of a couple of our new features. And if you're interested in seeing more, please visit logrocket.com or reply to the email with the webinar introduction, and we'll be happy to jump on a call and show you more. Now I'm really excited to introduce Joe Emison, co-founder and CTO of Branch Insurance, who has an awesome presentation prepared.
Excellent. Yeah, if you don't mind kicking one more slide forward. And I always like to start with quotes, and this is one of my favorite quotes about business. This is investor Peter Lynch, who loves to say that at any point in time you might have geniuses at the beginning, but the best businesses, and I would argue the best engineering, exists such that you can continue to replace people over time, maybe not with the best, so that it's still functional. And so if you want to go to the next slide, my maybe less pejorative engineering version of this is that we should try to write software that the average developer can support, because eventually that's who's going to be supporting it. And I think overall that there's not enough thought goes into how we can be designing and building systems that can be easily maintained. And there's a corollary to writing easily maintainable software and easily maintainable systems, or at least systems maintainable not by top tier geniuses. And that is that we should be writing less code. Code at its core is a liability, and it's something that you have to maintain. And so to the extent that we can leverage services, that we can leverage not only kind of API-based services, but also infrastructure as a service, and we can use it, that reduces the amount of code that we have to write and will give us these more maintainable systems. So if you want to kick to the next slide, let me give you an outline of what I'm going to talk about today. So I want to talk about what I mean when I say serverless, and then why you should apply serverless and how you can think about applying serverless at a high level. Then I'm going to go into some very specific serverless application architectures, because I think a lot of times, until we get to the specifics of how we can build things serverlessly, I think a lot of times it ends up feeling like a bridge too far to get to for most people who are enmeshed in non-serverless ways of building things and just aren't quite sure how you would get from where they are to a serverless mindset, a serverless architecture. And then finally, I want to talk about a lot of the focus that happens when you move to serverless, which is that you get to spend most of your engineering time on the front end, and why that's great, and some thoughts about how we at Branch do that and think about it. So great, let's start with what I mean by serverless. So to me, I'm always confronted with the question, well, aren't there still servers in serverless? I think a good answer to that is, well, there are still wires in wireless. It's just you don't have wires on your device. And so the same thing exists in serverless, although perhaps it's better to talk about serverless as these two observations. So the first one, no server ops, means that there are no operations that, say, a systems administrator or an application administrator would do on a server. You don't need to do those. That's fundamentally that is fundamentally the benefit of serverless. And we'll go into detail in a future slide just to highlight what a lot of those things are, because I think even with modern DevOps, there's still a tremendous amount of friction and pain that those server operations will cause you, patching, and especially around sort of forced updates. That serverless just takes off your plate as something you need to worry about. And then the other part of this definition, though, is this not our uptime. So I want to be very clear about this, because this scares a lot of people, especially operations. Sorry, you guys still hear me okay?
Now we got you.
Okay, sorry, yes. So in not our uptime, what I mean is that our uptime is completely controlled by not us. If we go down and we wait for our providers to bring us back up. This is very scary to a lot of operations people. And it may be scary beyond that cohort, but we really don't control our own uptime at all anyhow. We're reliant on the power company, we're reliant on internet upstream providers, we're reliant on a variety of different providers. This is just another step of yielding, but there is a large contingent of people who like to touch and feel their servers. And fundamentally, serverless means you don't get to touch and feel your servers. I mean, cloud means you don't get to touch and feel your servers. But if cloud is moving from thinking of servers as pets to servers as cattle, serverless is not having any livestock at all. And so, this is an explicit choice. So I'm happy to take questions about this. This has not hurt me at all. I've had much better uptime running companies serverlessly than I ever did running with very good operations. Let's hit the next slide. So why would we go serverless? So the first thing that I think is really critical about software development velocity is that, well, if your company is increasingly a software company, then the future of your company, the growth of your company, the survival of your company is directly related to how well you can develop and deliver software. And so we should be looking at all of the things that make it difficult to more effectively develop and deliver software. And probably the primary thing that I see across many different organizations is that these cross dependencies and blocking dependencies are systematically slowing down software developers everywhere. And what I mean by this is you've got a dependency, if you're writing on the front end, you've got a dependency on the back end, right? Maybe you've got a dependency on the database team. Maybe you have a dependency on the DevOps team making infrastructure as code, right? Or maybe you have a dependency on the fact that you have only a limited number of environments and somebody breaks one of the environments. And you have a limited number of environments because you have to stand up all these virtual machines that cost a certain amount to run, and so you just can't run an infinite number of those. But serverless ultimately really rips down, in my experience, most of these dependencies that cause blocking, that cause people to say, well, I can't work on X because, and then, insert answer here. And so if you talk to any developers at Branch, what you'd find is, I mean, we certainly get blocked by things. I'm not saying there's no blocking anymore, but if you ask, do you get blocked by what other developers are doing? Do you get blocked by a dependency by the data team, the operations team, the backend team? What you'll hear is no. Those are not non-issues in a serverless environment. Another reason why serverless, which I alluded to before, is that code is a liability. The more code you write, the more code you have to maintain. Serverless allows you to write and maintain less code because you are fundamentally letting other people run services for you. Another benefit to serverless is that it's highly opinionated if you do it right. So, if you pick any service that you're using, it's well documented, it has APIs, they're updating it, and there's a certain way you use it. And so you can eliminate a lot of the arguments that you might have internally about how to do things. One really great example of this that I've seen is, we use Amazon Web Services AppSync service, which is a GraphQL API as a service. And by using GraphQL and by using the specific way that implements GraphQL, sending in requests to our backend functions, there isn't a lot of argument like you would get in, say, RESTful API design, or how are you going to handle things getting passed from front end to back end to data store. A lot of that's just already, there's kind of one true way to do it already. And you also get a nicely opinionated sort of microservices architecture, not in the bad microservices way, but in the good, let's separate code in certain ways so that we can, so that once we've got it separated, we can scale development more easily. That you get a lot more of that for free with serverless than you would otherwise. And then finally, everyone gets their own production equivalent environment for basically no cost in serverless. So every developer at Branch has his or her own completely separate Amazon account. Every environment has its own Amazon account, where we run a pool of 10 different Amazon accounts for all of the simultaneous CI and CD runs we do. And the total cost to us of these, we're nearing like 100 environments or 100 Amazon accounts. We spend about, the total Amazon cost is about $300 a month for all of that. And that includes, the tens of thousands of people we have weekly who are coming in and are production users for us. And so, if you're doing this and you're just paying per usage, it's incredibly low cost to run. Now, I mean, production is most of that cost. The developer environments are very little because you're just paying per use. So all of these are, really, I think, compelling reasons to go with serverless. So how do you do it? Mind hitting the next slide? I think the most important thing and the hardest thing in change in any organization, especially technical organizations where technology moves so quickly, but people who tend to be senior in position just don't have the time to go do the research on what has changed, and they've got good tools that have worked for them for a period of time. But I think fundamentally, the most important thing you have to get over as a team is that what you're trying to do is solve the business problems in the best way and not have the attitude of the person on the left here who says, why is all the cool stuff handled by the cloud providers and now I can't do it? And so, I guarantee you that to the extent you have an engineering team that takes identity around doing back-end scaling, load balancing, orchestrating Kubernetes, if that's part of people's identity, you're going to have a really hard time moving to serverless and getting these benefits. But if you can move to a more, hey, look, we're trying to solve this problem for our customers, for our business, and you focus more on the front end, right? Which is what your customers are seeing, what your internal users are seeing are those interfaces, and taking delight and joy in solving things that way. That's the principal hurdle in my experience for you to overcome. Okay, great. So now let's talk about architectures. So if you want to jump to the next slide. So I talk on serverless and have for, gosh, about 5 years now, 4.5 years now. And a very common feedback is like this one I got from a year and a half ago or so, which says, this talk struck me more as a how to build a web application with a collection of third-party services doing all the server-side work than a true talk about serverless architectures. Not all of us have the luxury of being able to build something useful by gluing a bunch of other APIs together. And what I will say is this person fundamentally understood my talk and didn't ask, is this possible? And certainly we at Branch have plenty of back-end custom code that we need. So, I mean, this isn't like my view, serverless is not Yahoo Pipes 2020. Serverless is very much about how do I leverage services so that I don't have to do undifferentiated things that my customers, that don't make any difference to my customers. So if you want to hit the next piece of feedback, this is another one from Hacker News. And we got this, again, very similar attitude. He is operating the mindset that the backend is just a dumb persistence layer with auth. If all the problems we solving fit into that worldview, then more power to him. I'm a backend team lead for a travel company. To render that list of flights and hotels to the Android app, it's not a database lookup. It's hundreds of SOAP and REST calls stitching together airline and hotel data from multiple platforms. This isn't something I can do on the front end. And even if I could, I wouldn't want to replicate this logic between iOS, Android web, and our internal support portal. So here's someone who sort of understands what I'm saying, but completely misses how much you can do in the back end that's serverless. And so I thought it would be useful to take what this person seems to think is impossible to build serverlessly and explain how I would build it. So fundamentally, let's just talk about what this application is. So what we've had laid out is there's some user management, sign up, sign in, sign out, forgot password, user preferences. There's some UI elements on search and purchase, right? So we're going to autofill criteria like airport codes. We're going to submit search criteria. We're going to pay. There's some sort of share and modify UI as well, which is like maybe you're sharing your travel itineraries with people and you're going to change or including canceling itineraries. And then there's some back end, right? As he described, we're going to hit APIs in parallel, multiple APIs in parallel. We're going to coalesce those responses. We're going to filter them, and we're going to be able to purchase the itinerary. By the way, like hitting multiple APIs in parallel and coalescing responses through filters is very much what Branch does today. If you go to ourbranch.com, if you're in one of our live states, if you put in just your name and address, we give you a bindable price on home and auto insurance with just those two values. There's a ton of data calls. There's a ton of similarity between requesting a bunch of APIs from airline and hotel sites. JavaScript with ES6 is a beautiful language to do this in, which is sort of one of the primary languages of serverless in the back end. And then finally, there's some reporting. Right? I got to run some analytical reports on. And the short answer here is, I've laid out 3 different architectures for this, which I won't go into horrible detail on here. But I think that this is very easy to do with Firebase, and I think you would have a very small number of lines of code. I think you'd be in the 10 to 15,000. And I think if you did it on Amazon Web Services, you could probably drop about 3 to 5,000 lines off that. But I think you can be very, very low. And so I'll just give you the Firebase example here because I'm going to talk about an Amazon architecture later. But if I did it with, actually, if you want to stay here for a second, if I did it with Firebase, we can use a search service called Algolia. Algolia is like a serverless Elasticsearch. It's way easier to integrate in your application than Elasticsearch. Auth0 is an amazing authentication system. Handle all of your user management. Does SAML integration if you wanted to do that. OAuth, fantastic user management, auth management. Firebase, great backend as a service to store data. Firebase supports cloud functions, so you could write your backend code to go hit all those APIs, and you use Stripe for your payments to close those payments. And then finally, for reporting, you could Firebase has cloud functions that that sends things directly into BigQuery, and then you can run all your reports out of BigQuery, which is actually what, even though we use Emison at Branch, we use BigQuery we shuttle data using a service called Fivetran to BigQuery, and we do all our reports out of BigQuery. And so, this isn't a hard thing. I mean, this exact problem could be solved I think, in a much more efficient way with much less code than presumably what they're doing at this site, which is having to maintain VMs and they're probably having to deal with Kubernetes, et cetera. So great. So let's move on to the next example. I got two more for you. So Spaceful. So I started a company in late 2015, and we developed an application that makes tour books for office space search. So this happens if you're looking for office space. You get a broker. That broker picks a bunch of places for you to look at, and they, generally speaking, before Spaceful, would make a PowerPoint presentation for you and like print it to PDF. And then, of course, things would change right before the visit, and then the data would be the PDF would be out of date, and it would take them hours to put together. And then it wasn't very useful. It wasn't a very useful tool after the fact. So we built this application that was all online, so you could make changes in real time. You could edit the thing in real time with other people on your team. You could share it with your clients. You could either make a PDF for them, or you could share this mobile web app with them, which they wouldn't have to log into. There was just a custom link for them. And then the broker who shared it could see all of the interactivity that was there. They could see like, oh, these clients are actually looking at these listings. And then it would allow the clients who are looking for office space to upload images of the office space they were looking at. And so all of this was great, worked really well. And you can see this architecture that we laid out on it. And we had like more than 1,000 brokers using it. And so one of the best observation about this is we only had front-end developers working on this. So I was the CEO of this operation, and I did all of the operations work on it, and it was probably like 30 minutes a week after the initial week. It was very little. So great, let's roll to the next slide. And then finally, I just want to talk about Branch and our architecture. So Branch is, again, as I said, name and address to bindable home and auto prices for most people. And so we moved from what I talked about in the prior ones, the Firebase architecture, to one using AppSync. And I think that there are a variety of advantages of AppSync over Firebase as it exists. A huge one, as I talked about, I think, is GraphQL. There is also just less code involved, and AppSync is nicely integrated into the Emison ecosystem. So there are a number of calls, like if you're a client of Branch and you log into your customer portal and you're retrieving your details on your policy, those details on your policy is a direct call to Dynamo, and your documents are a direct call to S3. And so there's actually no code, there's no backend code you're hitting from us at all. And so if you think about how amazing that is, these are what are called AppSync resolvers, which basically take a GraphQL call into AppSync and transform it into an API call to DynamoDB. And then just retrieve the data from DynamoDB. And by the way, they wrap all of it in auth from Cognito. So these are authenticated calls. So you'll authenticate into Cognito, that'll give your user ID to AppSync, and then AppSync knows to only retrieve your documents and not somebody else's. And so it's just an amazing way to handle things that everybody does, right? Everybody has to authenticate. Everybody has to, have a reset password. Everyone has to have some sort of access controls on who can access what data. And so in this world, it's incredibly simple and incredibly low code to stand something up that can interact with your front end code, which is the next and last section we're going to get to is on front end. But within this back end world, we're able to really limit what our custom code does. And largely what our custom code does is it retrieves data from APIs and it applies logic to them. And then it sends that data back. It's just doing things that you wouldn't want to do in the front end because you wouldn't trust the front end to do it. So happy to answer any more specific questions about this architecture, but let's roll into the front end piece. And so I'll just talk briefly about branches, front ends, and then a couple more general observations. So branch runs 3 React applications and 1 React mobile application. These are, at this point, they're around 80% of our code base. And in terms of current work being done, about 95% of commits are on the front end. And so and this includes bug fixes, everything, operations, all work there. And so it's such an enormous benefit that whenever we're in demo meetings and doing presentations, everything essentially that gets presented is something that's highly relevant to the business leads who are in the demo meetings because it's all interface, right? It's like, okay, well, we made this interface change as you requested. And then we can, we're added this feature flag and we're A/B testing, and here are the 2 A/B tests. That's the vast majority of work we do. It's the vast majority of what we look at. And, I'm from 10 years ago, I was regularly in meetings where, someone would say, well, what is that developer doing anyway? Or what are we paying that person to do? Because I don't really understand it. Those conversations don't happen. I mean, I have such a high alignment between the developers that we have and what they're working on, and really high visibility to everyone as to exactly what business value that has. Great, so let's talk about a couple more things. So we use React and React Native. And that's a decision for 2 reasons. So one of them is, I think that despite there is some desire to bash JavaScript frameworks because they're big and they're heavy. And so, I see sort of an increasing groundswell of, vanilla JS, or, well, I'm just going to keep using jQuery because it works fine and it's smaller. And I think those are very nearsighted views. I think that if you're trying to deliver the experience that people want and expect today from high-end user interfaces, and you're trying to build a maintainable system, then you need to use a JavaScript framework. I don't think there's another good choice. I think everything else runs out, especially jQuery. We know where jQuery sites end. They end in horrific technical debt that are impossible to maintain. But I can tell you that that has not been my experience with React now in my 4th year of using React. Now, why React over Angular or Vue? Well, one of them is, so I've written a number of applications and overseen applications written in Angular, and I can tell you that I feel like it's just too magical. That's the best way I've heard the complaint about it, which is to say, sometimes you can do very little and it just works, but occasionally you don't want a behavior that Angular is exhibiting, and you just can't figure out how to change it. It's not, you don't have the level of control that you need to deliver the user experiences that you want. And so React does not have that problem. Another huge advantage to React, in my view, and I think this is similar with JavaScript as a language, is that React has taught us how it can introduce breaking changes across versions that you can upgrade into. And I think Angular and now Vue are teaching us they don't know how to do that. And so they're just going to break things so badly that you fundamentally have to rewrite. And so React and React Native have this wonderful ability, even though we will complain about it endlessly, that it can take a day or many days to upgrade to a new version. But in that process of that upgrade, they're bringing us along. And so we stay endlessly new. We get to use hooks. We get to use the new ways of doing things. And we have this learning system to our developers. Our developers sort of learn like, okay, well, every once in a while, or like every couple of months, we're gonna throw away something we did and we're gonna replace it with something else because it's better. And that's exactly the attitude we should have in software development today because of how quickly things advance and get better. And then finally, let's talk about the observation end for Branch. And so, one of the things that's so important when you get so front-end focused is you really need to understand what is happening. And your visibility from the front end is so much worse than your visibility from the back end because your code is running on another computer that you don't control, right? On a smartphone or on someone else's desktop. And so this is one of the reasons we use both LogRocket and Sentry, and they integrate together very well as our principal way to understand what's happening on our code executing remotely. And so and we also run Sentry on the back end, which lets us coalesce all of our error reporting into one system, which is really nice because sometimes there's an error on both sides. Some examples of why this matters. So it's incredibly important for our marketing department to understand, and our sales to understand, do people understand how to use our site, right? And so while you can run usability tests, and we do, we pay people to do usability tests. And when we pay them to do usability tests, it distorts their interactions. They pay more attention, they care more. And so with LogRocket's ability to recreate and give us a view into what people actually did, right, and how they actually reacted, that's an enormous benefit that allows us to iterate so much more rapidly around usability and around user understanding than we could any other way. I mean, it's really inaccessible to us otherwise. Another thing that's amazing about especially the LogRocket Sentry integration is that when there is an error, we are able to go and recreate essentially or re-see what the user session is from the Redux data store contents to the actual requests that are being made and what would have shown up in the JavaScript console in the browser. We get all that information in line with where the error happened. And then another huge benefit, especially around the metrics right now, is that within the metrics, there's always this ongoing discussion, I find, with marketing, which is that marketing says, well, I'm looking at X metric and it takes 87 seconds for the page to load, right? And we're saying like, well, we don't know, but how do we know that? And the amazing thing about LogRocket is LogRocket not only will give you those paint metrics and those load metrics, you can get this, you can get the actual network stream, right? So you can show like, okay, well, that one person you were talking about like had all these timeouts and retries on all of these files, but hey, check out, here's the totality of like that set of people in that part of the country or within that geographic area. And this is the general experience you're seeing, and you can kind of watch all of those develop. That's absolutely amazing and having much better conversations on those fronts. And so we use a ton of services. As I recommend, you should use as many services as you can to not reinvent the wheel. But for us, like this LogRocket plus Sentry gives us this amazing visibility into the executions that are happening on these remote machines. And so with that, I'm at Joe Emison on Twitter, happy to answer questions and always happy to answer anything on Twitter.
Thank you, Joe. That was fantastic. So we have a couple questions I'd just like to go over real quick. One is, how often do serverless providers make breaking changes to their APIs? And how easy is it to respond to these? I imagine it would be similar to upgrading OSS components.
It's interesting. So, I mean, if you were going to talk about a lot of times when people talk about serverless, they're talking about functions as a service, which are the ways to run functions on the back end. So this would be like AWS Lambda or Google Cloud Functions or Azure Functions. And what tends to happen with them is that they will deprecate runtimes. So in like say the Node.js and with Node.js runtimes, they will so they Node.js 8 you can't make any new functions with. And Node.js 10 is, I think, the current stable, but they also support 12. And so I would imagine in about a year, they're going to roll 10 off for new functions. Now, if you've uploaded old functions, they'll continue to run the old functions on the old runtime. You just, there's a period of time where you can't do new ones, and there's a period of time where they won't let you even update them. You have to move. And so those are the most primary breaking changes. Generally speaking, moving up a version of Node or a runtime in your application doesn't change too much, although it can. And then the other thing would be if you're using API services like Algolia or Auth0. My experience with those services they never deprecate. Well, not never. Auth0 has had to deprecate some things, but honestly, they gave people like 3 years to get off the older versions of what they had. And I think they didn't even end up forcing people off on that. So I think in general, they're pretty good, but I also think, especially with respect to your runtime, I think you're basically given, say, 6 months notice, and then you bake it in, and then it's not in my experience, not that bad to upgrade. But and by the way, I think all this is net good. I think we should be sort of reevaluating these core systems regularly. Otherwise, we end up, with what a lot of people have, which is, they've got like a PHP application that has to run on a totally insecure version of PHP and like no path forward. I think it's a lot better if you get in the regular habit of having to like move up to a new runtime or new versions of these frameworks. And so we don't find it horrible. But is it 0.5% of the time we spend every year in development? Like probably about that.
Great. Then the next question, sort of adding some context. I know we touched on AppSync briefly, or you touched on AppSync briefly, but they're definitely interested to know and what your experience with AppSync has been. We have been using Prisma for almost 2 years, and it has been the single biggest contributor to our speed and success with development.
Yeah. So I haven't used Prisma. Prisma used to be called GraphCool, I think, right? I haven't used Prisma since then, so I couldn't compare the two. I can tell you that AppSync is phenomenal. I wouldn't build greenfield on anything differently right now, just because one of the challenges with some of those other applications that I laid out is that you have multiple single points of failure. And one of the benefits of like living everything in the Amazon environment is, you tend to not have, right? Like you don't have all these different services that all have to be up. Now, to be fair, we didn't really have many outages at all when we had those multiple single points of failure. But I do like being fully within Amazon, and AppSync has been absolutely incredible. But I certainly don't have I have a very positive view of Prisma as well. So if I were successfully using Prisma, I don't think I'd move off.
Excellent. So one other question we got, Joe, was you had touched on sort of this concept of iterating quickly. So being able to see your users, iterate. Can you explain how you go through that, sort of what you're looking for when it comes to iterating quickly, and either just, how you do that with LogRocket, with Sentry, or just even in just like product, overall product, just, I guess the actual question is, how do you iterate quickly within your product while it's live?
Yeah, sure. So, I think, so one thing is that let me recommend the best book written on software development in the last decade, which is called Accelerate by Nicole Forsgren and Jez Humble, and I think a couple other people. If you haven't read it, and if you want the cheap version of it, they interviewed all of them on the A16Z podcast once. But the book's well worth it. And so I think that book is the best description of the things that you need to focus on to iterate quickly. And so it talks about these 4 important metrics, which are, and one of them is, you know, how often you release. So obviously, if you're not releasing multiple times a week, you're going to have a hard time iterating. And if you have to roll back a lot, or it takes you a lot of time to resolve errors, those are also going to be problems. And if you can't build things quickly, that's also, and you can't get them to release quickly, that's also going to be a problem. So all of those things you have to do correctly in order to iterate quickly. And then the next thing is that you have to aggressively downscope your work, and you have to be okay being somewhat embarrassed by your first version of anything. So from a principal perspective, I think all of those are the most important things. And what I would say that we generally do is, you know, we identify a problem. We will spend as much time as we need to in design if it's interface. And so that's one of the things that I think people probably rush too much on, is they have a problem and then they say, well, let's just hack a design in. But I think it's really important to go through like a real designer who's going to put the real designs in the right place. Like we use Zeppelin to transfer designs to developers, and Zeppelin has like design systems in it, and it can do a lot of things to eliminate technical debt and make your code more maintainable in the future. And so if you do this the right way, then you can end up spending a fair amount of time on design. But then if you downscope it appropriately, then when it actually gets to a developer, it's usually pretty small for V1. And so this is a constant conversation we have when we're specifying things. It's like, is this good enough for V1? And then just one other observation is, you know, you really want to get developers, designers, and your business leads together to have these conversations, and everyone needs to listen to each other, right? And so the most healthy way to downscope is to allow the developers and the designer to throw out alternative solutions to the problem than the one that might have come from, you know, the business lead who says, well, why don't we just put the button here and make it do this, right? And so, you know, over time, if you do this the right way, then what you get is the initial scope of work is always like, here's the problem I'm trying to solve. And then everything tends to be better that way.
Excellent. So another question we have here is, with the expectation that anything we implement will be outdated or even deprecated within 5 years of release, how do you design for replaceability in your architecture?
I mean, you just try to write as little code as possible. You know, I think, and you also want to reward people and be judicious about removing code. So we have internal rules which are essentially, look, if you see something that needs to be refactored, like just you know, make that ticket and let's combine it with something next. You know, let's combine it with the next thing that touches that, and then you'll just take the time you need to throw it away. But yeah, I mean, I think that you just have to get aggressive about throwing things away. You got to get aggressive about not writing code. But that one of my aphorisms that I say a lot internally is, it's a lot better to take 2 weeks to research and 2 days to develop than to take 2 days to research and 2 weeks to develop. Because even though both of them are 2 days and 2 weeks, at the end of one of them, you've got 2 weeks of code you got to maintain. And at the end of the other one, you have 2 days of code you need to maintain. And maybe you're paying, you know, $100 a month to a service provider or something, but you know, that's obviously, I mean, this should be obvious to everyone, hopefully, that maintaining 2 weeks of code is a whole lot more expensive than paying $100 a month in perpetuity to a third-party service.
Great. And then just one final question to be respectful of your time, Joe. Can we just go over just what is the overhead like to install a program like LogRocket, as well as how do you sort of get past the concept of like viewing your customers?
Yes. So let's see. So in terms of installation, I think, you know, it was probably, we already integrate with Segment, so we kind of boosted onto the Segment call. We did an override on the call we were making to Segment and to also send to LogRocket. And so, you know, I think it was like maybe 15, 20 minutes, and then PR, test pass, and we merged. So it was very little effort. You know, I think, so we're a regulated insurance company. We have agency, and we make sure we have a clear and correct privacy policy, and then we mask customer information, and so we're not interested in understanding any PII or really any personal information through any of these reconstructed system interactions. What we're interested in doing is just understanding who is confused about what, or what is working and what is not, and helping solve problems that people are running into. And so I think it's always really important for everyone to have an information security policy, to classify information, and to make sure that you're censoring information where you should be censoring information. But yeah, it's worked well for us so far.
Excellent. Well, I think that's all we have for now, Joe. I know there are other questions in the chat, so I will try to get those to you. For those on the call, if your question was not answered, feel free to follow Joe on Twitter and ask him on there, or feel free to reply to us via the email that was sent to you. I'll be more than happy to get it to Joe and get you the response. Finally, if there is a recording of this webinar, will be sent out to everybody who registered, and look forward to having some future webinars. So finally, Joe, thank you again for taking the time today. We really appreciate it. And for those of you who want to learn more about Branch Insurance, please visit ourbranch.com.
Yeah, great. We are live in Arizona, Ohio, Missouri, Illinois, and Texas.
Fantastic.
Please give us a visit.
All right. Well, thank you, Joe. Thank you, everyone.
Thank you.